Today we're going to talk about how to make compounds, which is combining two or more elements together to make something new, and then we're going to go over how you name those compounds. Okay, so a compound is what you get when you combine atoms of different elements. So these are molecules that have more than one different type of atom in them. All right, and so an example of this is something you come across every day in your life, sodium chloride, which is just table salt. And what I want to emphasize here is that the properties of the elements that you start with, in this case sodium and chlorine, are not necessarily the same as what the properties you get when you have a compound that results from them. So sodium is a metal that's extremely reactive. It explodes or creates fire when it's placed in water, and I think you would know that that doesn't happen with salt. And chlorine is a yellowish green gas that is poisonous. And while there may be some health concerns with eating too much sodium chloride, in general it's very, very safe, and we put it on our foods all the time. Okay, another example is water. Water is the combination of hydrogen gas and oxygen gas, which come together to make water. And they come together in a ratio of 2 hydrogens to 1 oxygen. All right, so this brings me to the concept of chemical formulas. So the symbol for hydrogen is just H, and the symbol for oxygen is just O. And we bring them together to make water. So we know we want an H and an O in there, but I just told you there's 2 hydrogens for every oxygen. So the chemical formula for water is H2O. So a chemical formula includes the symbols for both of the elements, and then it also includes what we call a subscript, which means it's a number that's written down lower and a little bit smaller for the number of atoms of each type of element that are present. Now that we know we can make compounds and we have a system in place for writing their formulas, it would be really helpful if we also had names. And so there are a few guidelines that can help us figure out how to name compounds. The first one is that the name of the element that's the farthest to the left comes first in the name. So for example, when we put sodium together and chlorine together to make a compound, sodium is farther to the left because it's a metal, and so it comes first in the name. So the name for that is sodium chloride. Okay, so the second part of the first guideline is that the second element in the name, the ending gets changed to "ide." So instead of sodium chlorine, we change it to sodium chloride. The second guideline is that when you have 2 or more compounds that use the same elements but different numbers of them, then you add prefixes to reduce confusion. So an example of this would be carbon and oxygen can come together to make carbon monoxide, which is just 1 carbon and 1 oxygen, or they can come together to make carbon dioxide, which is 1 carbon and 2 oxygens. So the prefixes that we use are mono for 1, di for 2, tri for 3, and tetra for 4. You will notice, though, that mono is frequently omitted from the first word in the name. So I didn't call it monocarbon monoxide, it's just carbon monoxide. So if there's nothing in front of the name, you assume that there's just one. And you'll find that the guideline 2 is really only used when both of the elements in the compound come from the upper right-hand corner of the periodic table, which is where the nonmetals are. So when there's a metal present, like sodium above here, we don't use the prefixes. The third guideline is that atoms can clump together and form a molecular unit that acts as a single electrically charged group, which we call a polyatomic ion. So for example, the carbonate ion is a carbon and 3 oxygens, so CO3, and it has a -2 charge. So we write it as CO3 2-. And there are several of them. There are only a few that I expect you to know. And you can find that table in your notes or on page 74 in your textbook. So when you use these, or when these are present, you use those just in place of the normal atom name like you would normally. So for example, if there's carbonate in a compound and it's paired with potassium, then that would be called potassium carbonate. In this case, even though it's written second in the compound, you don't change the name of the, don't change the ending to "ide." Now, the fourth and final guideline is that although we have these rules in place, there are a lot of compounds that are referred to by their common name or convenient name. So water is one example of this. So water should be, by our rules, be called dihydrogen monoxide or dihydrogen oxide, but we don't call it that, we call it water. Ammonia, which is NH3, is another example, and methane, which is CH4, is another example. I don't expect you to know these except the common ones that I use over and over again, like water, for example. Now that we have all these rules in place, let's go ahead and do a couple of examples. All right, so the first one is Li2O, and we have lithium, which is all the way in the first column. It's an alkali metal, so it's the one furthest to the left. So lithium, and then oxygen would be the next one, but we want to change the ending to "ide," so this would be lithium oxide. All right, the next one is HCl, and H is hydrogen, and Cl is chlorine. So we want to take a look and decide, are we going to use the prefixes or not? And we could in this case because there's no metal, but these are both just one of each, so we're just going to keep it simple and call this hydrogen chloride. Okay, the next two both have nitrogen and oxygen, so this tells me for sure that we're going to have to use prefixes. All right, so the first one is going to be nitrogen dioxide because there are two oxygens, and then the second one is going to be dinitrogen tetraoxide. So tetra meaning 4 and di meaning 2. All right, the next one is going to be potassium is K, and that's a metal. It's all the way to the left. And CO3 is one of those polyatomic ions that I just told you about. In fact, this is one we went over. So this is potassium carbonate because carbonate is the CO3 ion. All right, and then finally, now we have aluminum, which has a subscript of 2, so we know we have 2 aluminums. And then we have SO4, which is sulfate ion. And then that's in parentheses, and then there's a 3 outside. This means that we have 3 sulfate ions altogether. So just like in math, parentheses means you would distribute everything inside, distribute to everything inside. So this means we have 3 sulfurs, and then we have 3 of the O4s, so that we would multiply, and we would get 12 oxygens. Okay, so this is just a clarification about the chemical formulas that you might not have seen before. Okay, so then to name it, we have aluminum, because that's the farthest to the left, and then sulfate, which is the polyatomic ion. So this is just aluminum sulfate. All right, now that wraps up our conversation about naming for today. We're going to do some more practice of these in class.